Welcome back. In this video, we're gonna find the exponential form for this complex number, the square root of 3 plus I. Remember that the algebraic form of a complex number is z is x plus iy, with x and y real numbers. Okay, and I is the complex number that satisfies I squared is minus 1. Okay, so this is the algebraic form. For the exponential form, we will have to write z as rho or r e I theta. So some notations, they use r e I theta. So theta is the argument of the complex number, and rho or r is its norm or modulus. Okay, so remember that if we have a complex number zx plus iy, so its norm is the square root of real part squared plus the imaginary part squared. In our case, if we call this our z, then the norm of z is gonna be the square root of 3 squared plus 1 squared, which is 3 plus 1, which is 4. That means the norm is 2. Okay, so here what we can do is the following. When we want to write z in this form here, once we find the norm, this is rho. In fact, this is rho, this is r, depending on the notations. So once we do that, we write z as 2ei theta. Okay, but after that, we see that we can write this one as 2 cosine theta plus I sine theta. Remember, this is coming from Euler's formula. Okay, and next we can do the following. Okay, so we can factor out this number in such a manner that we factor out by its norm. So its norm is 2. So now we have square root of 3 over 2 plus I over 2. Okay, remember this one here. Okay, so it's like we did nothing. Okay, but it's important to note the norm here, always positive. Now we're gonna identify these two. Okay, here we see that from here, we see that the real part is equal to the real part, and the imaginary part is equal to the imaginary part. Remember, when we have two complex numbers, z1 equals z2, these two are equal if and only if the real part of z1 is equal to the real part of z2, and the imaginary part of z1 is equal to the imaginary part of z2. That's what we do here. Therefore, we conclude that cosine theta, square root of 3 over 2, and the sine of theta is 1/2. Okay, remember the unit circle. An angle that has sine of theta as 1/2 and cosine of theta as the square root of 3 over 2. So it should be here. Exactly. So this is my angle. This is my theta. So this is 1/2. I'm assuming this is 1/2, and this is square root of 3 over 2. What's this angle? So this angle has its cosine is positive and its sine is positive. It's the only angle that we know is pi over 6. So that means our theta is pi over 6. Therefore, I can go back, and here I can write z as rho e I theta. I know the norm, it's 2, and I know theta is pi over 6. And let me write it nicely. It's 2e to I pi over 6. And this is square root of 3 plus I. Okay. Very nice and very useful when we need it, especially in electrical engineering and mechanical engineering or space engineering. We need to have to know this one by heart. Okay, so that's the key. So you need to know how to do these ones. I know that you're good in this, but this is just a reminder. So remember this key idea here, and what else? The exponential form, the algebraic form. Okay, and the norm. Okay, the norm is here. So this is the definition of the norm of a complex number. Okay, I think that's all. Please like, share, and subscribe. Thank you very much.